Method of contraposition. So recall that for statement for any x in domain D, Px, then Qx, if you have an implication, well, the contraposition says for any x in D, not Qx, then not Px. This is the definition of contraposition. So if you have a statement in implication form, instead of proving the implication, you can just switch to its contraposition and try to prove the contraposition instead. For example, here you have a theorem. Or let us just write a proposition. Take a look at this proposition. This proposition proposed that for all integers like n, if n squared is even, then n is even. Very good. So how do I prove this? You might say, hey, I want to prove this using direct definition. Proof. If we try to prove it by direct definition, this happens. For all integers like n, if n squared is even, it means that you can find some integers that n squared is equal to 2k, for example. Okay, so now how do I show that n is even? So n is equal to plus minus square root of 2k. And then how do I show that n is even? I end up with a square root. Well, it's easier to use the method of contraposition. Let us try to use the method of contraposition. So what's the meaning of that? It means that we rewrite the original statement. We rewrite the statement using its equivalent statement. Okay. For all integers n, not even. So for all integers like n, if n is not even, then n squared is not even. Very good. We try to prove this statement instead. Very good. The proof is not that hard. It says for all integers n, if n is not even, since n is not even, n can be written as 2k plus 1. Okay, n is odd. So, and k belongs to an integer. Okay, so n squared is equal to 2k plus 1 squared, which is 4k squared plus 4k plus 1, or if you factor out 2k squared plus 2k plus 1, this guy is another integer. So n squared is equal to 2l plus 1. So n squared is not even. We just proved that n squared is not even. We started from the hypothesis and proved the conclusion. So we proved this statement, which is the equivalent of the original statement, is true. It means that our original statement is true. So we prove that the contraposition is true. So the statement is also true.